The first law is the conservation of energy. Energy can't be created or destroyed, it can just be converted from one form to another. In scientific terms, the total energy in an isolated system stays constant. You can convert it from one form to another, like from potential energy to kinetic energy, but the overall amount stays the same. For example, imagine you're holding a ball above your head. That's potential energy. But when you drop it, it becomes kinetic energy. And when it hits the ground, that turns into heat and sound. But the energy never just disappears. Every roller coaster, bouncing basketball, and even your microwave relies on this law. The next law is the conservation of momentum. Momentum before a collision equals momentum after, unless of course an outside force says otherwise. This law tells us that in a closed system, the total momentum of all the objects remains constant unless acted upon by an external force. For example, picture two ice skaters pushing off each other. They glide in opposite directions with equal and opposite momentum. No friction, no loss, just physics and dramatic exits. This principle is why car crashes, billiard shots, and even space travel can be calculated down to the tiniest motion. Next, we have Ohm's law. Voltage equals current times resistance. In electric circuits, the voltage is equal to the current multiplied by the resistance. It's the backbone of how every electronic device works. Think of electricity as water in a pipe. Voltage is the pressure, and resistance is how narrow the pipe is. The more voltage and the lower the resistance, the more current flows. Next, we have Coulomb's law. Coulomb's law states that like charges repel and opposites attract. This law tells us that the force between two charged particles is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. For example, two balloons rubbed on your head repel each other because they're both negatively charged, but the balloon and a wall, they attract. It's science, not sorcery. Next, we have Faraday's law. If you move a magnet near a wire, boom, there's electricity. It's the physics version of just add motion. A changing magnetic field induces an electromotive force in a conductor. So basically, by moving a conductor within a magnetic field, it experiences a changing magnetic field which induces an electromotive force which is responsible for the flow of current within that conductor. Basically, motion plus magnet equals electricity. Now, for Lenz's law. Lenz's law states that the direction of the induced current from Faraday's law will always oppose the change that caused it. It's like physics saying, not so fast, buddy. For example, drop a magnet down a copper tube. It falls in slow motion, not because of the friction, but because it creates a current that pushes back. No batteries, just raw electromagnetism. Lenz's law is nature's way of keeping energy honest. Now for Boyle's law. Boyle's law states that for a fixed amount of gas at a constant temperature, pressure and volume are inversely related. Lower the volume, pressure goes up. Let it expand and pressure drops. For example, that hiss when you let air out of a tire, that's high pressure air expanding rapidly into a low pressure environment. That's Boyle's law in action. Now we have Heisenberg's uncertainty principle. Heisenberg's uncertainty principle says that the more precisely you know a particle's position, the less precisely you can know its momentum and vice versa. At the quantum level, particles are fuzzy. Try to pin down an electron's location and you lose track of its speed. Nature doesn't let you have both. It's not being difficult, it's just quantum rules. And those are all the laws of physics, at least the major ones. And if you like this video, please subscribe. We're very close to 1,000 subscribers. So please subscribe, comment, like, and share the video, guys. Thank you.